This is the most important one, and in most of the interviews, they might or they may going to ask you this question. Okay. Can someone explain the architecture of Kubernetes? I mean, this is where it is I mean, if someone who is new to Kubernetes, most of your doubt will be cleared. Like the thing which we have discussed, like the scaling, the monitoring, how it's going to create all these new containers. So can anyone explain the architecture of Kubernetes? And just to make things simple, let me, we can pick any of these images. Yeah, I can. Yeah, David, please go ahead.
Hi, good morning, Prashant. So I think the overall architecture of Kubernetes, um, it contains two types of servers, I guess, control plane servers or the worker servers, or they call it nodes. So control planes are responsible for the overall operation of the cluster. They manage all the pods that run on worker nodes, and they're also responsible for monitoring and restarting pods, whereas the worker nodes are uh, uh, more for running your actual containers.
Yes, that is absolutely correct, David. Uh, from interview point of view, they want to ask you some more in depth about all the other components of like control plane or the worker node. Do you want to take a stab and want to answer, explain those components also? In the control plane, you have the other component, right? etcd, API server, kube proxy, and kubelet. Any idea what is the role of all these components?
I think scheduler is responsible for scheduling the tasks like we in the operating system we have a scheduler, right? So basically, which is responsible for whenever there is a queue, there is a kind of a middleware queue which have a couple of tasks, and I think it is responsible to manage those tasks. I think on a hindsight, I am aware that Kubernetes has as David said, Kubernetes has a master and a worker terminology, like a master slave in client server terminology. So the master is responsible for mostly all of the components like the API server, which this component is running on the master node, which is responsible, which is working as the front end, from where you can manage the GUI. I think I have not used it, but that's my understanding. And Kubelet is, I think, another agent which is running on all the nodes, including master as well as worker nodes. I think which is responsible for the communication between those nodes, a master as well as when some worker node container goes down. I think that's how master gets to know, and it just promotes some another master or something like that. And yeah, I think Q proxy is also another agent kind of thing. But yeah, that's my understanding.
Okay, so I can get started. What you guys have described and just try to explain it in a more elaborate way. So we have two components, what we have seen in that diagram, control plane and workers, right? Control plane, as you can think it of, is like something which is going to control the whole cluster, right? So this is like a master who is going to guide what is going to happen. Workers, as the name explains, where exactly your work is going to happen, where exactly your container is going to run. So that is where the work of a worker. Now in control plane, the most important component is API server. So API server, you can think of it like a brain of a Kubernetes. All the instruction which is going to happen is going to go via the API server. So let's say I want to create a container. So that first call to create a container is go via the API server. API server will see that if that is possible or not, and that we are going to see how that API server is going to handle that. Okay. So think of it, it's like brain. Everything which goes to a Kubernetes goes via the API server, no matter what. Okay. And trust me, we are going to go into details of what exactly that is going on at the API server level. Okay. Now the second component is called scheduler, like Kamal has mentioned. Scheduler, as the name suggests, it is going to schedule something. Okay. Uh, I will go just 1 minute in depth of like how exactly the scheduler will work. So let's say, and we are going to see in depth of this one, how this whole things work. So let's say I want to create a container, and in the Kubernetes world that is called pod. Okay. And that container required, I'm just taking some arbitrary number, 5 CPU, okay, and 100 GB of RAM. Simple, right? Or 100 GB is too much. Let's say 10 GB of RAM this container required. Okay. So what exactly the scheduler will do, and like I mentioned, all the work, all your container is going to run on the worker node, right? So let's say you have like 3 worker node, worker node 1, worker node 2, and worker node 3, right? And I'm just throwing an example. This worker node has 2 CPU and 20 GB of RAM. This worker node has 4 CPU and anything, 50 GB of RAM. And this worker node has like 20 CPU and 100 GB of RAM. So for the first stage, how the scheduler will do, it's going to do something called filtering. Okay. And it knows that, okay, my requirement is 5 CPU. And these 2 worker node not even have the those much amount of CPU. So they will be already been filtered out, the worker node 1 and worker node 2. So that means then if it's possible, then the load will be scheduled to this worker node 3. Okay. Now the question is, in case, let's say this worker node 2 have like a 10 vCPU and same 50 GB of RAM, and this one we already know it has a 20 vCPU and 100 GB of RAM. What do you guys think? Where exactly the scheduler is going to schedule the load, or you're going to schedule your container? We know this is completely out of picture because this is not even satisfying my requirement of 5 vCPU. But out of this worker 1 and worker 3, where do you guys think the node is your load is going to be scheduled, or your container is going to be scheduled? This is one of the questions which has been asked in the interview. It depends. Okay. So like I said, the first stage is the filtering. So in filtering, it knows that, okay, it filter out the worker 2 and worker 3. Okay. Now there may be a possibility that in worker 3, we have the other workload which is already been running. So let's say we have like a 10 other containers which are running. And those 10 containers already occupy this 10 CPU. Or let's say they already occupied like close to 15 vCPU or CPU in simple sense. So it only have the 5 CPU left. Okay. So then in that case, it's going to schedule onto a worker 2. So I mean, it depends upon a lot of other conditions, but I'm just giving you the high level overview, how scheduler looks inside these worker node and try to schedule the load. Okay. Now, the third component of that is called controller manager. Okay. Controller, sorry, not controller, controller manager. This is one of the other most important component. How this is going to work is, like I mentioned earlier, there are a lot of controller manager inside the Kubernetes, and we are going to see few of them today. I can give you one controller manager, and there's one concept you are going to see a lot in, if you are going to read all books and all the docs. It's called reconciliation. What the concept is like, in case, one second, reconciliation here. So in case, in my Kubernetes definition, I say that I need to spin up this 5 pods. Let's use the word pods now. Pod, you can think in the simple terms, it's a containers. Okay. So there may be something which I mentioned to you guys earlier, that there may be something which need to monitor these. That these 5 pods always should be up and running in your Kubernetes cluster. So this is what is called a desired state. Right? We always want the 5 pods to be up and running in our Kubernetes cluster. So this controller manager, one of the component of controller manager, keeps on checking if the 5 pods are up and running. And in case if any one of these pod goes down, it will try to restart that particular pod. Or in other words, I will say it will try to bring up that pod back. So that is how a Kubernetes always maintain that desired state. Okay. So these are the three main components. And there is one more component called HCD, which is other most important component. And simple way you can think of it is key value database. Okay. So anything which is happening on the Kubernetes cluster, API server will store all this information in the HCD database. Okay. So let's say a simple command to the Kubernetes cluster. And like I mentioned, API server is the brain. So from the customer end, you are asking that in Kubernetes cluster, how many pods they are running. So what will it will do that the request will come to the API server. It will look to the HCD database and give you that information back to you. Similarly, if I want to spin up more container in my cluster, that request again comes to the API server. API server will store that information back to the HCD database that now we have these many number of containers running in my system. So everything, I mean, think of it like a database for your cluster where all the information are getting stored. Okay. Natively, Kubernetes has these 4 components. But if you look at the picture, like here, there is something more, there is one more component which is called Cloud Controller Manager. Okay. And this is specific to a cloud. Okay. So if you are going to spin up a cluster in your local environment, and we are going to see it, I think right now after this, is called a cloud controller. This component will be missing. But in case if you are going to spin up a cluster in cloud like AWS, GCP, or Azure, there is one additional component which is responsible for communicating to your cloud provider. Okay. So I can give you an example of, like, for example, EKS, AWS EKS, and this is the one which I have mostly worked on. Is that, let's say I'm going to spin up this one of the container, and again, container and pod, I'm intermixing all those things. And in that container, I need 10 GB of disk space, right? My partition should be of 10 GB. So what this cloud controller will do, and again, this is something to do with the volumes and something, and we have the PV and the PVC claim and all those things, and the storage classes. What this will do, it is responsible to communicate to the EBS, Elastic Block Store. You might be heard about in the AWS space, or there is EFS and all those things. So using this Cloud Controller Manager, you can talk to these EBS and EFS and get your container that much amount of desired space from EBS. Okay, so this is just one example, but Cloud Controller Manager is specific to the cloud. It has nothing to do with the native Kubernetes component. Okay, so this is a main. These are the main component of control plane, and that's what I have mentioned earlier. Like why Kubernetes is complicated, because Kubernetes has so many moving parts, and in case if something happens, you need to debug all these components. Okay, I spent a lot of time in my company is to try to debug on-premise Kubernetes cluster, and trust me, managing Kubernetes is one of the most difficult things. So what most of the people do is that this control plane, if you go to any of the cloud provider, for example, AWS, Elastic Kubernetes Service, Kubernetes Service. AWS will take care of this whole of these components. You just need to spin up your cluster, and AWS will take care of this control plane component, all of these. And you just need to focus on worker node. Okay, I will spoke about one more thing which will take care of the worker node also, but at the high level, you can think it of, if you do not want to manage all these components and you want your cloud provider to manage those components, then in that case, you can spin up into some of the cloud provider who is going to take care of this component for you. Okay, And I mean, like based on my experience, spinning up 1 pod, 10 pod, 100 pod is perfectly fine. The moment you start hitting the limit, like for example, if you want to spin up again, just to oversimplify it, 1,000 container, 15,000, 10,000 container, then you will start seeing a real issue. And in a really big cluster, you have all these like Kubernetes, all these pods or container running. Okay, so in that case, it's better to go with, or based on my experience, it's always better to go to a cloud provider to spinning up your own, to spinning up the Kubernetes cluster. So this is all about control plane.
Yeah, Prashant, for the etcd part, so are we using any database, or it is up to us? Like, can we use Redis as a key value store database or something else?
So I haven't touched, to be honest with you. I mean, natively Kubernetes comes with this etcd database. Okay, and this control plane. I mean, you can use the other database provider also, as far as I have read it, but I haven't used any other database. Okay, and the other thing is, sorry, I forgot to mention, in case of AWS, if you are going to spin up this control plane, by default, it will spin up in 3 availability zone, just for high availability. So in case if one of the your AZ goes down, just to confirm, it's AZ, not region. So it's specific to 3 AZs. So AWS is going to spin up your control plane to 3 availability zone. So that means you have the 3 etcd at the backend also. Like you have your data is getting stored in 3 different locations, or your cluster data is getting stored on 3 different locations. So to answer your question, Kamal, etcd is the default one. I think Kubernetes support other database also, but I haven't tried it so far.
Okay, so no, I don't have any understanding with that is at etcd. So you mean to say that etcd itself is a database?
Yeah,
That's
it's a
right.
key value based database.
Ah,
Key value
oh,
store.
okay. And
And
the reason for 3 AZs is that because I have read in the clustering that how it works, like there is a kind of a quorum concept where
Mhm.
you need to have a minimum of 3 worker nodes, so that in case there should not be any split brain issue, that if one of the nodes goes down, then it would be then if there won't be any elected master, then your cluster gets into unstable state. So is it the reason that the same concept here, that there are 3 AZs?
no, I mean, that's a default concept of a, like, that is not specific to Redis. That is a default concept of clustering, that you at least have the n number of node, or like a odd number of node to maintain the quorum. But here is just to do with the availability. So if one of the
Okay.
AZ goes down, you should have somewhere where your Kubernetes cluster is up and running.
Yes, Prashant. AEC, is that a concept in AWS specifically?
Yeah, it's availability zone. So basically, I can give you an example of, like, for example, US West 2, the place where I'm in the West Coast, right? So in the West Coast, this location is called Oregon. And in Oregon itself, AWS has the 4 data center: US West 2A, 2B, 2C, and 2D. Okay. So each of these is called availability zone. And they are like 100 miles apart, at least 50 to 100 miles, as per the AWS documentation. So if something happens in this 100 miles, at least this data center will not be impacted. So that's the main idea behind the AC. And this whole thing constitute is called the region. Within the region, you have this AZ, and AZ itself is like geographically distributed. And then if you are aware, then they have something called US West. Don't remember, it's called 1A, right? US West 1, which is in this East Bay in San Jose. They have the data centers. So basically, the idea is to reduce the blast radius and to have the data centers in different geographical location. So let's move to the second part of this equation. We have seen the control plane or the master. And again, I'm saying, if you can see like how much complex is that, you have all these components, and on the top of it, now you include the cloud. So cloud has this other component called Cloud Controller Manager. Okay. Now let's look at the worker node, where you have something called kubelet. Okay. And you have something called kubeproxy. Now, kubelet is something which is responsible for spinning up the container workload on the worker node. Okay. And like I mentioned, worker node is something which is going to take care of like where exactly your work is going to happen. So how this is going to work is like kubelet, where you're going to spin up run command. It's going to contact the API server. Okay. And API server, depending upon how much permission this kubelet or the user who is running those Kubernetes command has, and then API server is going to give him a permission to spin up the nodes. And then all these other components will kick off. For example, scheduler will see if this node has if this worker node has a capacity to run the container. Controller manager is going to going to continuously follow up or going to check it out if and if that pod is up and running. And then ultimately the data will be stored on etcd. Okay. So kubelet is the one which is going to create a request and contact the API server. I mean, not only the kubelet, but anything which is happening on the Kubernetes cluster, everyone is going to talk to the API server. Kubelet is just a worker node component part. Okay. Now let's look at the kubeproxy. So kubeproxy is something how the different containers or different pod on the worker node is going to communicate to each other. Okay. So now you have like different pods here in the container in a worker node. So in order for those to communicate with each other, this kubeproxy is responsible for that. Kubeproxy is basically for the communication part. Okay. So worker node is pretty simple. You have just these two components, but on the, or they have also called something called container runtime, which the most famous one is Docker, but now we have other container D and Rocket also. So like I mentioned, the control plane component, if you go with the EKS managed solution, AWS will take care of it. Okay. You only been responsible for this worker node. So you need to spin up this worker node, create this node, you need to manage it, you need to patch it on a regular basis. In case if there is a new version of Kubernetes available, like I think 1 or 2 days back, now they have released 1.28. So in case if you need to upgrade to this version, you need to upgrade the worker node also. So that is all these things only you need to take care of this worker node. Or in case if you do not want to manage this worker node also, you just want to run your workload, right? The code you have written, you just want to run that workload. There's something called a AWS offering called Fargate. So in case of Fargate, AWS will even take care of this worker node. Okay, you just need to tell AWS your requirement. So let's say I want to spin up a container or a pod with 1 CPU and I'm just throwing a number, 1 GB of RAM. So AWS will in the backend will create all these environment for you. You don't even need to worry about this worker node. But as already I mentioned, like you need to pay extra to AWS for managing this. In this case, in case if you don't want AWS to manage it, what you can do, you can use a EC2, right? EC2 instance, set up the node, right? And add that node to your cluster, to the control plane. Okay, and there's pretty good documentation like how to add the node to the cluster. But in case if you do not want to manage the worker node, you can go with a solution like Fargate, where AWS will even take care of managing your worker node. The only thing you need to do is to create your YAML definition files, create your your Docker image and everything, all those things which you need to manage. The rest of the things, AWS will take care of it. Okay. So please remember these components. This diagram, at least, I mean, I will say everyone should learn by heart, and they may going to ask you in interview. Most of the cases, they start with like the first question in most of the interviews that I have seen, that how much experience you have in Kubernetes. The next, they will talk about the project you have done, any significant project you have done on Kubernetes. And based on that, they might come up to this question. I mean, 9 out of 10 times, they're going to ask you this question, like explain the Kubernetes cluster architecture. Okay. Any question before we move to the next topic?
Prashant, so if your application is hosted on AWS and using their supported Kubernetes, does that mean you hardly ever need to dive into these different components like API server, scheduler, etc. for troubleshooting? Is it all well managed by AWS, or can it well manage it?
Yeah. So for if you don't even, I mean, you're talking about the Fargate solution, right? So even if you are not going with a Fargate solution, this control plane is managed by AWS, right? Unless or until you are going to like you will set up your own EC2 instance and create your own Kubernetes cluster. So yes, in that case, yes, all the overhead will be taken care by the AWS itself. But Fargate, based on my experience, is a kind of an expensive solution. And there are companies who do not want AWS to manage your worker node. So in those cases, you need to go with the earlier solution where you led AWS to take care of your control plane, but the worker plane, you or your team will be responsible for managing it.
Okay, thank you.
And Prashant, regarding the terminology like pods or operators, so they are not part of the architecture, like they are different, they're outside of this.
So, I mean, this is the high level architecture, right? After that, if you need to go inside all these components like pods, services, deployment, ingress, and all those things, I mean, that is a component which you are going to build on the top of it. But at the above, like if I told you like, okay, just forget about Kubernetes for timing. If you need to spin up a virtual machine, you spin it up, right? I mean, whatever, that's the high level. After that, what you are going to run on the top of it, you are running Apache server, Nginx server. That is where all these other things, yeah, like pods, services, they will come into play.